last transformations we're going to look at is the reflections. So if you have a reflection in the x-axis, we are actually going to see that the image of x will be the same, but the image of y will be a negative y value. So determine the rule for the function f of x equals 1 over x squared after a reflection in the x-axis. So we can just look at it the normal way where we make the whole function negative, and that's what I've done here. So I've said that it would be the whole function negative, which therefore we get this answer. But if we use the image formula, so we know that the x didn't stay the same and the y was negative. So if you were to rearrange that, really it's like a -1 there. So if you bring it over, it just makes the image negative as well. So if you wrote out the function y equals 1 over x squared, then put in what y equals. Well, y is negative y and x is still the same. So you can see, well, essentially when you have a negative, well, you want y by itself. So it's like saying -1y equals 1 over x squared, but you want y by itself, so you move the -1 over and it ends up being, it becomes negative. Okay, so you can get the same thing. So another type of reflection. Okay, the last transformations we're going to look at is the second one, where we reflect in the y-axis, and so this is where we see the image of x becomes negative, and the y remains, image of y is the same. So if you have a look, if you look at it the normal way, you just make the x value negative in all the functions. So it's f of x, negative x. So you do that. If we do the image way, so we said image of remains the same, but the image of y, x becomes negative. And if you transpose that, well, we'd say negative equals x. So we're going to put that into our formula on that. So we had y equals square root x. So y was the same, and everywhere we saw x, we put negative x. So you can see we get the same.